Hello and welcome back to another McGill Academy module. In this particular video, we're going to be focusing on assemblies. So what I've got here is a cylindrical component with sort of a mini shaft sticking out and cut into it on both sides, as well as, if you'll notice, a cubic component right here. Now, for the purpose of saving RAM, what I'm going to do is I'm just going to close these files. So we'll close that one as well and go into our assembly file. So I just pressed File, New, and selected Assembly. Now the first logical step is to insert component. And you'll notice we don't have any components that are open right now, so SOLIDWORKS automatically opens up this prompt. And what I'm going to do is I'm going to hold Control and click on both of these components. You could have also used Shift to select multiple. But you press Open, and you'll notice that it puts it in one at a time. So we're going to start off with the cubic component. So our graphics preview, as you can see, is on, so it'll give us an idea of where it's going to go. So I'm going to click once, and then I'm going to click again. And there we go. We've got our first parts in our assembly. Furthermore, if you want to incorporate more of these components, you could use the Insert Components tool, but the more convenient way would be to hold Control on your keyboard, hold down the left mouse button on when you're selecting one of these objects, and drag. Easy as that. Now you'll notice we have this little F beside the first cubic component, the first object that we uploaded into this assembly file. And the whole idea with that is the fact that if you have this F, it means it's fixed. So if I hold down the left mouse button and move this, I can move these objects freely. No issue at all. But for this particular object, I can't move it at all. So to undo that, you just right click and press float right here. Furthermore, you could also rotate your objects by holding down the right mouse button and moving it around like so. Simple as that. Logically, our next step would be to incorporate the mating function. So the Mate tool is extremely useful. You're going to be using it a ton when you're making assemblies. And essentially, it allows you to merge two objects together at certain junctions. We're going to go over all the standard, advanced, and mechanical mates. Less of an emphasis on the mechanical mates, but yeah. So for our first mates, what I'm going to do is I'm going to press on this top face, and I'm going to select this extrusion here. And you'll notice it automatically sets a coincident mate for us, meaning they're supposed to be touching or sort of aligned in the same particular direction. This will be perfect for the fact that we need to adjust a certain depth for this particular shaft to go into this object. For our next mate, what I'm going to do is I'm going to press on the cylindrical face of this extrusion, and I'm going to select this inner cylindrical face here. And you'll notice if I press OK there, first off, it's got a concentric mate there. I'm going to lock the rotation and press OK. You'll notice it's already selected. As well, before we even enable that concentric mate and go into our Mates tab and click on this concentric mate, you'll notice it gives us this mate alignment tool as well. So right now it's anti-aligned. If you press aligned, you'll notice it flips it up to the other possible solution for this object. In our case though, anti-aligned would work better, and we saw that evidenced by our concentric mate right here. So that's how you make one particular small assembly. And if you want to be a little bit more organized rather than having all of these different particular components here, what you can do is go in this drop down menu and press New Assembly. And you'll notice we have this here, so I'm going to click both of these cylindrical components and drag them into our new assembly. Easy as that. Furthermore, we can enable different types of mates for different objects. So for instance, if I click this face here and this face here, you'll notice it automatically resorts to the coincident mate. So it aligns it so that they're touching in some regard. But this isn't the only solution we have here. We could also make the two faces parallel to each other. So in this case, they're not necessarily touching, but whatever you do, they're always constrained to have these two faces parallel to each other. So say if we want to move this object, you'll notice it will never shift its orientation. They will always follow each other in some way. The whole idea with mating is the idea that with adding more mates, you're adding more constraints, you're restricting more points of freedom within your object or your whole assembly. So the more mates that you could give this software, the better your model will be, the more rigid it'll be. But I'll always advise caution when using these mates, just so that you don't particularly screw up regions of your model. So like there's instances where it creates errors for itself. Furthermore, to further demonstrate, you could also put a perpendicular mate. And you'll notice these two faces are perpendicular to one another at some particular angle. However, just like these cylindrical objects, what we want to do is we want to make these two cubic objects connect. So what I'm going to do is I'm going to select this face here and this face and create a coincident mate. That's all good. And then what I'm going to do is I'm going to click this interface here and this face here, the corresponding face. That'll work. And you'll notice we'll need another form of mate. So what I'm going to do is I'm actually going to click here and hide this front cubic assembly so I can actually see what I'm doing. And click on this bottom tab and then unhide that first cubic component and click there. And you'll notice it's perfectly lined up. That is all we need for that. Now, I can understand, it's a little bit tedious to constantly have to go into this mating menu and, clicking faces. It's annoying, and I get that entirely. So a more convenient way of creating mates is holding down the Alt key, holding the left mouse button on whatever component, one of the faces you want to mate, and dragging it to that corresponding face. So this is what we've done. And you'll notice if you let go and both of those sides turn blue, it'll automatically create a coincident mate, in this case for us. So I'm going to say, okay, that's perfectly fine. And just to make it a little bit more convenient, I'm going to fix this front object so we don't have as much movement as we see before. Next up, I'm going to select this front face here, because I can, and plop that down there. And then if I move this out, and select this side here, this is fully mated. You'll notice if I unfreeze this, we can move this without any problems. Beautiful. We have more mates at our disposal too. If we press mate and select this face here and select this face, you'll notice it makes a tangential mate, which is pretty cool. I like that. If you go into your anti-aligned mode too, you'll notice it gives you two different solutions, one on this side of the cylinder, one on the other side of the cylinder. So that's particularly useful. You also have the lock mate, which essentially just locks two components together. So what that means is whatever you do to one, so if you move one around, the other will always follow suit in its particular orientation. This is particularly good if, say, you have a model that's constantly changing, but one distance needs to be fixed the whole time. The lock tool is always at your disposal. As well, what you could do is you can use a distance mate. So I removed the lock mate on this lad right here, and you click distance here. And you can set multiple options for it. I'm going to say let's let it be at 3 inches. And currently it's at a center-to-center distance from this particular object to this particular object. But you could change that. It is entirely up to you. And the same thing applies for angles as well. So say if you have two objects that you want, at certain angles from one another, typically works with planar surfaces a little bit easier. You use the angular mate. However, now we're feeling a little bit more spicy. We're going to move on to the advanced mates. So we're going to start off with the profile center mate. This is Honestly, I don't see how this could be an advanced mate. It should be in your standard mates because it's exceptionally useful. You can click a profile, you can click another profile, and using the profile center mate, you'll notice they are perfectly aligned according to their particular profiles. So what it does is it takes the center of whatever face you've put and the center of the other face you put, and it puts them together. And what do you know? We have this weird caterpillar type thing. Also, another thing that I forgot to add earlier on is, say if your objects are in weird places relative to your assembly. So what you can do is you could press this particular button here, so View Origins, and you'll notice the origin of every single model in this particular assembly is shown. So these are the origins of each of these particular cylindrical components. These are the cubic components, and then this is the origin of your assembly. And furthermore, if you want to align these, what you could do is you could click that point, you could click this point, and boom. What do you know? You have aligned your origins. That's particularly useful. Furthermore, if you'd like another nice way of lining up your object, what I'm going to do is I'm going to select the plane according to this cylinder here. And I'm going to go into Advanced Mate. So I'm going to click Symmetric, and this is selected. And essentially what the Symmetric Mate does is it places your symmetry plane, which I've selected right here, in between two different objects that you put in here. So you'll notice it's done this. This is its anti-alignment, but yeah. Currently, if you look at this model, this cylindrical assembly is right in the middle of this cubic assembly. So again, that helps out a bit. Now, for the latter half of our Advanced Mate / Mechanical Mates tutorial, what I'm going to do is I'm going to set up this sprocket and shaft system that I've had from before. So my first step is going to be to mate these shafts. So what I'm going to do is I'm just going to make a coincident mate with this particular portion here, and press OK there. And then furthermore, this is already mated perfectly. It'll be fine. Next up, what I'm going to do is I'm going to take this lad here and mating it there. Nice. And I've already set this up before, which is why this sort of fit snugly. But note that that's not always the case. Next, I'm going to take this guy and I'm going to make him coincident there. And this guy's already coincident here. So yeah, no need to do anything there. And I'm going to hold, so I'm going to move this guy out of the way. I'm going to hold Alt and bring him onto this shaft here. And press lock rotation. So as you see, if I press the right triangle, or right button, sorry, we are moving the shaft. I'm going to do the same for this guy here. And press lock rotation. Beautiful. Now you'll notice with regard to this particular assembly, we can move these sprockets freely. No issue about that. But the only thing is we want them to be constrained to this shaft in some particular way. So the way to do that is using the width mate. So you go into Advanced and press width. So this is already selected. And the width mate is very nice in the sense that it allows you to set boundaries of sorts. These width selections, think of them as like your endpoints. So I'm going to click this face here, and I'm going to click this face here. Furthermore, for our tab selections, it's more or less the object that you want to constrain. So I'm going to click this face and this face here. And you'll notice it's automatically centered because the centered constraint is enabled. But know that you can change that up however you'd like. So if I put free, for instance, and say OK with that, I can't go past this point, but I can still move this object freely, as the name insinuates. If I edit this, though, and go into dimension, you could change up how far. So say we want it only an inch away from this pink arrow. We can do that. We only want it 0 inches. We can do that. We're going to stick with the centered constraint. And we're going to do the same for this buddy over here too. So press width, click that, boom, boom. Where's the bacon? There it is. Nice. For our next mate here, what I'm going to use is the Pathmate tool. So you go into Advanced Mates, Pathmate, and essentially what it allows you to do is you select a point on one object and you select a path. And by doing this, essentially this object is fixed to this circular path here at one particular point, that point you selected, that vertex you selected. So if we move this object, you'll see that they move around. It'll actually be easier if I fix this guy. So let's go back into our assembly here and press fix. My bad. So if we move this guy, you'll notice it is anchored at that one point. Also note that I deleted the origin mate that we did earlier on. So if you remember, if we press the view origin button, if you have that enabled, you won't be able to move this guy around. This circular object would move instead. In addition to our previous mates, we also have the linear coupler. I don't necessarily have a model ready to demonstrate how this works. This is sort of a similar way, but essentially you set a ratio of, this is a ratio of movement. So say you want this to be a 3:1 ratio for your object, your blue object, which is our cubic object, and your purple object, which is our cylindrical object. If we press OK here and go out, you'll notice if we move these, they'll have to move at a certain ratio at one another. So again, this works very well with linear slides. But again, I'd advise, trying this out in different situations and seeing what works best for you. You won't come across it too often as well. So I'm going to delete that guy, and I'm going to show you our final distance and angular mates. So these are exactly similar to our standard mates of distance and angle, except these ones lock your objects in a certain distance and angle, one particular value. The difference with the advanced mates is you can set a maximum and minimum value. So say we have this face here, we select, and we have this face here. You'll notice it's already at our distance that we selected, 1 inch, but I'm going to select a minimum distance of 1, and a maximum of 10. And if I press OK and try to move these guys around, they'll move in tandem with one another. So as soon as it hits 1 inch, it pushes up. As soon as it hits 10 inches, it pulls down. Simple as that. And the angular mate works the exact same way except with angles. So you can restrict it between, say, 0 and 45 degrees. You have two planar objects and they can't surpass that. Again, play around with it a bit more, but those ones are pretty linear to use. For our final mate, I'm going to be showing the gear mate. I'm going to delete this one just so I can start from scratch. But you'll notice the largest difference from before is the fact that I drew in this circular sketch of sorts. And the reason why I've done this is this represents how large our sprocket is. It's just a very general way of determining the ratio of the sprocket. So when we use the gear mate, you'll notice it'll ask for two mate selections. So I'm going to select this guy and this guy here. And since they're the same size, they'll have the same ratio. But note that if these circles, if they were sized differently, or if you had another measure of measuring the dimensions of the sprocket, these two objects would actually move at a different pace. So they'd move at different speeds of one another like an actual gear / sprocket system would. But if we press OK and close this, hold down the right click on doesn't matter where, these two objects will move in tandem with one another. So that's very nice, especially if you're trying to do a motion study of any sorts. As well, for you perceptive bunch, you'll notice we have another patterning tab as well. I'm not going to go over all these patterns again. I'm just going to demonstrate the linear component pattern. But note that if you want a tutorial on how each of those individual patterns work, check out our featuring video. And the reason for that is the two are directly analogous of one another. They are the exact same. So what I'm going to do is I'm going to select these two components to pattern, or these two right here. And I'm going to click a direction for the pattern. So say we'll click that axis. And you'll notice, just like a regular linear pattern would for a feature, we've created duplicates of our assembly. Very nice. And they'll move in tandem with one another because that is how they are constrained. In addition, we also have the Move Components tool as well. So this is exactly like if you were to hold down the left mouse button and drag your models. It does the exact same thing, you'll notice. And again, you can see that all these objects are moving in tandem with one another because of their constraints, because of the mates we've set. But the nice thing about this tool here is it allows you to use collision detection. So as the name insinuates, if I were to bring this guy and tap it against this guy here, it'll create an error sound. It is not very good. You can also stop it at collision, so that isn't possible. As well, it allows for physical dynamics. So if you move these objects, they'll sort of work and operate like an actual physical object would, and it could change the sensitivity of that as well. Finally, we also have our Rotate Component tool, which, as before, has the exact same options as our Move Component tool. It's just now we are moving our objects angularly on an angular axis. As well, we have some of our featuring tools that we also had in our previous modules as well. So again, I'd advise looking at the featuring tutorial to get a better idea of how each of these works. We've gone over hole wizard, simple hole, extruded cut, etc. The same thing with reference geometry. Nothing has necessarily changed. So that pretty much covers the basics of assemblies. If you have any questions, please don't hesitate to contact us or check out our website, and we look forward to chatting with you. Thank you very much, and we'll see you later.